Okay, Shabab, welcome to part B of experiment 3. In part B, we are going to implement 3 OPAMP circuits. The first circuit that we are going to implement today is called the differentiator. So circuit number 1 today is the differentiator circuit, and it looks like this. This is our OPAMP. This is terminal number 2. Terminal number 3 will be connected to ground. Terminal number 2 will be connected here to a capacitor, okay, 1500 picofarad, and then the input signal will be connected here, and then here we have a resistor connected to the output, terminal 6. This is the output signal, okay. Again, terminal number 7 is connected to plus 15 volt, and terminal number 4 is connected to negative 15 volt. These are the DC, positive DC bias and negative DC bias, okay. And this resistor is 10 kilo ohm. Let's call it R1 or R, because we don't have except only one resistor here, and we are going to call this capacitor C. And then we are going to connect our input signal. This is the input signal. We are going to connect a triangular wave of 1 kilohertz and amplitude of 1 volt. How are we going to connect this? We are going to connect this from the function generator. So basically, you are going to take the wire coming from the function generator, connect the red terminal here and the black terminal to the ground, which is the same as the ground of the whole circuit. Okay, so the ground of the whole circuit. And by default, also channel number 1 of the oscilloscope will be connected here. Channel number 2 of the oscilloscope you connected here. So channel number 2, you should connect the red terminal of it to the output and the black terminal to the ground, okay, in order to watch the output signal. So basically, this is what you are supposed to do. You are supposed again to plot V output against time. You are supposed to give me results of V output against time, sketch V output against time with all amplitudes and all important time instants. You are supposed to calculate V output peak to peak, the frequency of the output signal, and the DC offset, if there is DC offset of the output signal. Okay, but in order to do that, we need to understand how this circuit works. So let me try to explain a little bit of theory behind the operation of this circuit. Of course, if we connect terminal number 3 to the ground here, and this is an ideal op-amp, this point will have 0 volt, right? Let's call the current here, we'll call it I. What's the current I? What's the current I and how it is related to V input? Now the voltage of the capacitor is V input, right? Because the voltage here is 0, the voltage here is V input, so the voltage across the capacitor is V input. And the current I is going in this direction, so I equals C dV input by dt. Do you agree with me that this current I is the same as the current that will go here? So the current that will go here is also I, because the current going to the op-amp is 0. If the current here is I, this volt is 0 and this volt is V output, which means that the voltage across the resistor like this is negative V output, right? If I put the negative sign here and the positive sign here, the voltage in this direction is negative V output, right? So negative V output will be equal to what, ya shabab? Negative V output will be equal to I multiplied by R. So V output will be equal to I, which is C dV by dt, multiplied by R, which gives us that the output will be the negative of the derivative of V input multiplied by the value of the resistor multiplied by the value of the capacitor. And again, this negative sign here because this voltage is V output, this voltage is 0, right? So the default thing is that the voltage here is higher than here. But if you put the negative here and positive here, the difference between this point and this point is negative V output. So negative V output equals IR, which means that V output equals negative IR, and I is C dV by dt. So this is the explanation of how the circuit works as a differentiator. Okay, the output will be the derivative of the input signal. So if you have a triangular wave at the input, what do you expect to have at the output? Think about it. If you have a triangular wave, this is the input signal. then the output should be kind of rectangular wave, right? Kind of rectangular wave, and with also negative sign. So it will be also multiplied by a negative. So if the slope here is positive, this will give you negative rectangle. If the slope here is negative, it's supposed to give you positive, and so on. Okay, so if this is the input, the output should look like this. This is the first circuit that we are going to implement today. The next circuit will be the difference amplifier. And the difference amplifier it looks like this. In the difference amplifier, we'll have two inputs, and we are going to kind of calculate the difference between them. So this is our output signal, terminal number 6. This is terminal number 2, terminal number 3, as usual. And terminal number 7 will be connected to plus 15 volt. Terminal number 4 will be connected to negative 15 DC volt. Okay, and then we are going to connect terminal number 2 to a resistor R1, which is supposed to be 1 kilo ohm. Terminal number 3 to a resistor, again same resistor, 1 kilo ohm. Okay, and then we are going to connect this to another resistor here. Okay, R2 equals 2 kilo ohm. And then this terminal will be connected to a resistor here, R2 2 kilo ohm. This is the circuit. We are going to feed this circuit with two input signals. Again, from the function generator, we are going to generate a triangular signal, okay, with 1 kilohertz and 1 volt amplitude. And then we are going to use the sync output from the function generator to generate a square wave. And as we said before, that this square wave, we have no control on the parameters of it. Which means that it is always, it goes from 0 to 5 volt, okay? And its frequency will be the same as the frequency of the triangular wave. So we'll have from the function generator, we'll have triangular signal, and from the sync output of the function generator, we'll have this rectangular signal connected like this. We are supposed to get the difference between the two signals, and in order to explain how we are going to get the difference, you have to do superposition. So let me try to do it quickly. If we do superposition, first thing, let's take the first input. So superposition means that the total output equals the output coming from the first input plus the output coming from the second input. Let's first calculate V output dash, which is the output coming from the first input. In this case, to do superposition, we are going to connect this to ground. We are going to assume that the second input is 0, right? In this case, ya shabab, first, this input is going to pass through a voltage divider. It's going to be divided between this resistor and this resistor. So the voltage here, let's call it V3. Let's call the voltage here, I'm going to write it in red. Let's call the voltage here V3. V3 will be equal to what? Now we are calculating V output dash, okay? V3 will be equal to what? V3 will be your V input 1, V input 1 multiplied by R2 over R1 plus R2, voltage divider. So this is the voltage of this point. After we calculate the voltage of this point, what is the voltage of this point? Again, it will be V3, same as the voltage of this point. This is an ideal op-amp, right? The voltage here equals the voltage here. Once we have the voltage here, V3, okay, and we need to calculate V output, first we can start by calculating what will be the current. Let's call the current here I. The current I will be V3 over R1, right? So I equals V3 over R1, and then V output equals what? V output equals V3 plus the same current will go here, okay, multiplied by R2. So it will be V3 plus I multiplied by R2, right? So V output will be V3 over R1 plus I V3 over R, it will be V output will be equal to V3 plus IR2, which is V3 over R1 multiplied by R2. This is I, right? So let's substitute for V3 here. If we substitute for V3 here, then V output will be 1 plus R2 over R1 multiplied by V3, which is R2 over R1 plus R2, okay, multiplied by V input 1. If you calculate this, you will find that this is equal to, you divide the denominator here, okay, it will give you R2 over R1 multiplied by V input 1. This is V output dash, this is V output dash, the output that will result from the first input. Like, what about if we take the second input? If we take the second input and do superposition, you are supposed to assume that here we have V input 2 and you are going to connect this to ground. So V output double dash, in this case, V output double dash will be the output due to the second input. In this case, let's just remove the red things here. In this case, if this is connected to ground, if V input 1 is connected to ground, this is 0, this is 0, this will be by default 0 volt because there is no current that will go in this part, and this will by default will be 0 volt. So the current that will go here, let's call it I, the current that will go here, it's V input 2 minus 0 over R1. V input 2 minus 0 over R1. I'm so sorry, this is not V. We are calculating V output double dash now. The current equals V input 2 minus 0 over R1. Do you agree with me? This is the current due to the second input. This current, as it is, will go here, right? In this case, V output equals what? In this case, V output double dash, okay, will be equal to negative I R2, which is negative V input 2 over R1 multiplied by R2. So this is V output double dash. Now the total output, V output total equals V output dash plus V output double dash, which is V input 1 multiplied by R2 over R1 plus V output double dash, which is V input 2 with negative sign, so it will be negative V input 2 R2 over R1. So basically, V output will be V input 1 minus V input 2 multiplied by a constant R2 over R1. That's why we call this circuit the difference amplifier. So what we did is we solved this circuit using superposition. We solved it one time by connecting V input 2 to ground, and we solved it for V input 1. We calculated V output dash due to V input 1. And then we calculated V output double dash due to V input 2. When we connect V input 1 to ground and we have only V input 2, we calculated V output double dash, and then we added V output dash plus V output double dash, and we found that V output, the total V output, will be the difference between the two inputs multiplied by a constant. So this is the second circuit that we are going to implement today, and this is the theory behind it, how it works as a difference amplifier. Let's talk about the third circuit. The third circuit is called voltage to current converter. What does it mean, voltage to current converter? Or what is the purpose of it? The purpose of a voltage to current converter is that you can control the current in a certain device, in a certain appliance, like a fridge or a computer. You can control the current by changing the voltage, the input voltage. So you can, by changing the input voltage, you can control the current of this device, regardless of the resistance of this device. Yani even if the resistance of this device changes, the current will stay fixed as long as you fix the input voltage. Okay, so here the current in your device, in your fridge, in your computer doesn't depend on the resistance of your computer. Whatever the resistance of your computer, the current will be constant, fixed, unless you change the input voltage. Okay, if you change the resistance of your computer, the current will stay the same. So the current here in your computer or in your device, in your fridge, depends only on the input voltage. You can control it only using the input voltage, not using the resistance of your device. Again, if you fix the input voltage, the current will be fixed in your device. Even if you change the resistance of your device, the regular thing is if this is your device, if this is your load, your computer, if you change the voltage, the current will change. This is regular. And if you change the device, if you change the resistance of the device, the current also will change. But here what we are going to do is we need the current in your device to depend only on the input voltage, which means that if you change the resistance, the current will not change. This is what we want to implement here in this circuit, is to make a circuit, to implement a circuit where we can make the current dependent only on the input voltage, not dependent on the resistance. Okay? How to implement the circuit? The circuit is implemented as following. This is our OPAMP. I'm not going to connect terminal 7 and terminal 4 as usual. This is terminal 2. This is terminal 3. We are going to connect terminal 3 here to a resistance called R, 10 kilo ohm. And here also we are going to connect it to R, 10 kilo ohm, same resistance exactly. And then we connect it to the terminal number 6, which is the output. Okay, then here Vx will be connected using a resistance Rx, and then to connect it to terminal number 2, and then here resistance Rx connected to ground. And Rx here we are going to use it 5 kilo ohm, 5 kilo ohm. Okay, and then here we are going to connect our input signal. So our input signal, we are going to use a sinusoidal wave, 1 kilohertz and 1 volt amplitude. This is our input signal, V input. And our computer, our load, we call it the load, our load will be here. This is our computer, your fridge, your computer, your TV. We are going to call it ZL, Z load, which will be 1 or 2 kilo ohms. Okay, so in order to understand how the circuit works, we need to do a little bit of analysis here. So first, let's call this voltage here, we'll call it V output, because this is the voltage that will affect your load. Let's call it VO. We'll call it VO, okay? This is the voltage that's going to affect your load. Of course, if the voltage here is VO, the voltage here will be VO, and the voltage here also will be VO, right? So voltage here VO, VO, VO. Okay? Fine. What else? This is V input. This is our input voltage. First, what's the relation between Vx and VO, ya shabab? If we have a voltage VO here, then the current I will be equal to VO over Rx. Do you agree with me that the current I here will be the same as the current I here? Then Vx, we can say that Vx equals the current multiplied by the resistor plus the current multiplied by the resistor. So Vx will be equal to IRx plus IRx. So 2IRx. So Vx can be written as 2 multiplied by the current Rx, which is 2, and the current we can substitute as V out over Rx multiplied by Rx. So Vx will be equal to 2 V out. So Vx equals 2V out. Good. طيب, let's call the current here. If this is 2V output and this is V output, the current here, we'll call it I. Let's call it I1. Let's call it I1. And let's call the current here also I2. What's I1? I1 that will flow here, I1 equals the voltage here minus the voltage here over the resistance over R. The voltage here is 2V out minus the voltage here, V out. Over this resistor is R, so this will give you that the current is V output over R. This is the current I1. What about the current I2? The current I2 equals V input, the voltage here is V input, minus VO over R. V input minus VO over R. Perfect. So we calculated the current here I1, V output over R. We calculated the current here I2, it's V input minus V output over R. Do you agree with me that I2, this current I2, it's the same as the current that will go here? So the current here is I2. Why? Because the current going to the op-amp is 0 ampere. If it is an ideal op-amp, the current going to the op-amp is 0 ampere. So all the current I2 will go here. What about the current that will go to the load? The current that will go to the load, I load, the current in the load equals the summation of I1 plus I2. Do you agree? This is the current law, right? The current law. I load, the current here equals I1 plus I2. So I load equals I1 plus I2. Let's add I1 plus I2. If we add I1 plus I2, it's V output over R plus V input minus V output over R. It will give you V input over R. So I load, the current that will go to your load, the current that will go to your load, okay, it's V input over R. It doesn't depend on the resistance of your load, which means that even if you change your computer, you bring any fridge, you bring any other computer with a different resistance, you bring any other device with a different resistance, the current here will be the same. You can control the current here only using V input. You can change V input or the resistance R in order to change the current in your load. But if you change your load, the current will be the same. It will not change. If you change the resistance of your load or you change your load completely, you replace your computer with any other device, the current will be the same. The current in your load will not change with changing the load. It will be fixed. Okay? It will change only if you change V input. That's why we call it voltage to current converter. We convert the input voltage to a fixed current in your load. So this is the theory behind this circuit. You are supposed to here measure the output current. You are supposed to measure the output current when the load resistance 1 time 1 kilo ohm and 2 kilo ohm. Okay. Try to see how the current looks like. Okay, and compare them. See whether the current will be fixed or not. Okay, and you report it in the report. Okay, let me see if there is something else for this experiment. Okay, so you are supposed to try. That's it for this experiment. You are supposed to plot the current. You are supposed to sketch the current in the load. I load with time for one time, one curve for Z load equals 1 kilo ohm, and another time for Z load equals 2 kilo ohm, and show me how they look like. Okay, they are supposed to be fixed unless it happens that the op-amp saturates at a certain level. Sometimes the op-amp will saturate, causing the voltage here not to increase above a certain limit, which makes the current in the op-amp also saturates to a certain level. Okay, shabab, that's it for this experiment, and we'll see you next week. Assalamu alaikum.